Alright, in the previous video we have learned 6 different types of graph data structure. Now in this video we will learn how can we represent graph data structure in our code. Now the first way to represent graph is using adjacency matrix. Basically, an adjacency matrix is a square matrix, or you can say it is a two-dimensional array. And the elements of matrix indicate whether the pairs of vertices are adjacent or not in the graph. So let's say this is our graph over here. We can easily see that this is unweighted and undirected graph. So this means that A is connected to B, and since we don't have any direction over here, we can also say that B is connected to A also. So similarly, A is connected to D and D is connected to A also, and it continues like this. Now, how can we represent this graph using adjacency matrix? So here, first we create two-dimensional array with the size of number of vertices in the graph. So if you look at in our graph over here, we can easily see that the number of vertices over here is 5. So we have 5 nodes over here. So this means that in this case we are going to create two-dimensional array with 5 columns and 5 rows. And when we create 5 to 5 matrix, we are going to initialize all elements of two-dimensional array with 0. Then the next thing that we are going to do, we have to plot these edges that we have over here into this two-dimensional array. So here we are going to check nodes one by one. So if we have connection from this node to other nodes, we are going to change the that cell's value to 1. So in this case, from A to A, we don't have any connections. From A to A, we will have always a 0. So if we continue this diagonal over here, you can easily see that it represents B to B, C to C, D to D, and E to E. So this diagonal over here will be always 0. Then we are going to check the next edge. So the next edge is from A to B. So this means that from A to B, this cell over here will be updated to 1. Then from A, we have next edge, which is C to C. So this means that from A to C, this cell over here can be updated to 1. Then from A, we have another edge. So this is from A to D. So this means that from A to D, we will update this cell over here to 1 as well. Now you can easily see that from A to E, we don't have any connection. So this means that this will remain 0. So as we said before, this is undirected graph. So we are going to continue to the next node. So in the next node, we have B. As this is undirected graph, from B to A, we have connection. So this means that from B to A, this cell over here will be updated 1. And from B to E, we have another edge over here. So this means that from B to E, we are going to update it to 1. Now from B to B will be remain 0. And from B to C, we don't have any direct connection. So it's going to be 0. And from B to D, we don't have any direct connection. So this means that this is going to be 0. Now then we are going to continue to the next node. The next node is C. Now from C to A, we have connection. So this means that from C to A, we are going to update this cell to 1. Then from C to B, we don't have any connection. So this means that it's going to remain 0. And from C to C, we don't have any connection. So it's going to remain 0. And from C to D, we have connection. So this means that it's going to be C to D cell over here will be updated to 1. Then we can easily see that from C to E, we don't have any connection. So it's going to remain as 0. So because it shows that there is no edge from C to E. Then the next node is D. So we can easily see that from D to A, we have connection. So DA cell over here will be updated 1. From D to B, we don't have any connection. So this means that DB will remain as 0. Then from D to C, we have connection. So this means that DC cell over here will be updated to 1. Then from D to D, we don't have any connection. So it's going to remain 0. And from D to E, we have connection. So this means that it's going to update it to 1 over here. Now then we are going to continue to the last node. The last node is E. So in this case, from E to A, we don't have any connection. So it's going to remain 0. Then from E to B, we have connection. So it's going to be updated to 1. So from E to C, we don't have any connection. It's going to remain 0. And from E to D, we have connection. So you can see that this is the edge. So we are going to update it to 1, and from E to E we don't have any connection, so it's going to remain 0. So as you can see, this diagonal over here remain 0. So this is how we are representing a graph in adjacency matrix. Now the next method for representing a graph is adjacency list. In this case, we are going to use linked list to save all links between the vertices. To make this very clear, let's see example over here. So here we have a graph like this. So in this case, we have 5 vertices in this graph also. Now in case of adjacency matrix, we have created 2-dimensional array with the size of 5 to 5. But in this case, we are going to create 1-dimensional array with the size of 5. Then we are going to initialize all vertices to this array over here. So our array will look like this, and we are initializing all nodes that we have over here, A, B, C, D, E, to this array over here. Then the next thing that we are going to do, we are going to insert edges between these vertices to this array over here, and this is going to be linked to each other. So here we can easily see that from A to B we have edge. So this means that in A we are going to create another node over here, and this is going to be B. And from A to C we have another connection. So this means that in the A over here we are going to create another node and link it to B over here. So this is basically we are creating a linked list over here. Then from A to D we have another connection. So we are going to create a new node over here, which is D, and we will connect it with the C over here. So in this case, when you go to the column A over here, you can see that from A we have an edge to B, to C, to D. Then we are going to continue to the next node. The next node is B. So from this graph over here, we can see that this is undirected graph. So from B to A we have connection, and from B to E we have connection. So this means that we are going to create 2 nodes over here. One will be A, then we are going to connect it to B, then another node will be E, and it's going to connect it to A. So with this, we can easily identify that from B to A we have connection, and from B to E we have connection. Now the next node is C. So from C we have only 2 connections, to A and to D. So this means that we are going to create 2 nodes over here, A and D. So it's going to be linked to each other over here also. So after linking them, we can easily identify that from C to A we have connection, and from C to D we have connection. Now the next node is D. Now from D we have 3 connections. We have 3 edges over here, D to A, D to C, and D to E. So this means that we are going to create first from D to A, then from D to C, then from D to E. So with this we can easily identify that from D we have 3 edges. Now at the end, from E we have only 2 edges, to B and to D. So we are going to create B node over here and link to E. Then we are going to create D and link to B over here. So basically we have represented our graph in case of adjacency list over here. So here the main point is we are storing vertices in an array and edges in linked list. But in the first case we were using array itself for storing the edges. Now you might be interested, if we have 2 types of graph representation, which one we should choose. So in this case, if the graph is complete graph or almost complete graph, then we are going to use adjacency matrix. On the other hand, if the number of edges are few, then we should use adjacency list. Now let's look at these cases very closely. So if we have a complete graph, it means that we have the maximum number of edges possible in our graph over here. So in that case, all cells of this matrix will be filled. So we are using 2-dimensional array very efficiently. So it means in this case we can use adjacency matrix. Now let's say we don't have enough edges in our graph over here. So this means that this is not optimum use of matrix over here, because of most cells over here will be empty. So this is not space efficient solution. So in this case we need to avoid adjacency matrix representation. In this case we can use adjacency list, because in this case all edges are stored in linked list. So depending on how many number of edges we have, we can increase or decrease the linked list size over here. So but in the first case we don't have such option. So we are just creating 2-dimensional array with the fixed size, so we cannot increase the number of rows or number of columns over here. So in this case, if we are not using all spaces over here, it's not going to be space efficient implementation. Now with this we have come to the end of this lecture. So in this lecture I have shown you how can we represent our graph in 2 ways. Now in the next lecture we are going to implement both ways in practice using Java programming language. So see you in the next lecture.